is truly the first. This is truly the first time I'm going to attempt calculus in 3 months. I haven't done this in a while. This problem is challenging. Let's see what we can do here with this problem.
Take two.
Cole Rose, by the way, mathematician. We have a conical tank, which is more familiar, right? It's 8 feet wide at the top, and it's 12 feet tall. All right, people. And it's full of water. Or no, it's not. It's full of cement, and the density of that cement is 112 pounds per foot cubed. All right. We have. We want to know how much work required to fill the tank with cement from the bottom. So it's going in this way. And work is a form of energy. It's, I think, weight times distance. So if you're picking something up, it's heavy, a certain weight. Or force times distance is work, I believe. Force times distance. Force, you got to use a certain amount of force and distance to take it. So how much force and distance is going to be needed, energy, to fill this tank fully up to the top. So what we're going to do here is we know that the volume of a cylindrical tank is pi r squared times the height. Now the height in this case is going to be dy, because we're going to measure the work in each sliver, as you would say, all along this as it's being pumped in, because you can't do it as a whole because the radius is changing as we go up. So we have to imagine it as a flat plate that's continuously going up, and we measure it in each radius along the way. And the way we're going to do that is we're going to use the radius in relation to y. Currently the radius is 4 feet at the top because the total diameter is 8 feet. But over the height, which we can call y, is 12 feet. So if we have the 12 radius times 4y, we can write the, which is just cross multiplying here. That's what we did. And then we can write the radius in relation to y by dividing both sides by 12. So that simplifies to radius is 1/3 y. So now we can rewrite this. Volume is equal to pi times the radius squared 1/3 y squared times the height, which is dy. We know that the distance is y. But we're going to be going all along here measuring the distance as we go up the radius. So it's going to be 12. Or no. Actually, it's from the top. So the bottom actually it's coming in from. So the distance is only going to equal y, because it's going to be just at that sliver each time we go up, and it doesn't have to travel from any specific feet in the air because it's starting from the bottom. So now what we're going to do here is we're going to write the work required, which is the density, which is 112 pounds, and we'll just write 112 since this is math here, we know. And then times multiplied by the integral, definite integral from 12 to 0, because we're filling it to the top, all the way from 0 to 12. Oh, that's going to be from 0 to 12. I'm sorry, because it's going from 0 to 12 here, and that's going to be of the volume here, which is pi over 9 y squared times the distance is y here, and that's going to be dy. So is that negative y? No, it's not going down. So yeah. Now what we're going to do here, no, this is still 12 to 0. Apologies. Alright, this is alright. Yep. We're going to use this calculator here to simplify this equation. 112 divided by 9 is actually not simplified. 112 over 9. And then we'll multiply the y squared by the y, which gives you y cubed dy. And then if we integrate this, we get y to the 4th over 4. Don't forget that it's a definite integral. From 12 to 0. That's 112 over 9. And then we can multiply that through 12 to the 4th power divided by 4. We're just plugging this here in ladies and gentlemen. That's going to be 5,184, because 0, if you entered it and subtracted it, would not matter. So 112 over 9 times 5,184 times gives us 64,512 foot-pounds. Now let's check my math here and see if that's what the professor got. He got, where is it? What number was that? 2? Professor got something entirely different. Now, what did I do here, guys? 28. Why? From 9 to 0? Are you fucking kidding me? What'd you do, Professor, you dick? Oh my god, that's problem B, I'm sorry. Actually, if you look here closely, I was looking at B. This is A. We got 64,512. Forgot the pi, I'm sorry. Pi, well, yeah, that's still right. Foot-pounds. That's what I got here. Okay, so the work required to fill this to the top with cement, with the density of 112 pounds per foot cubed, is 64,512 pi foot-pounds cubed. Or not cubed, because that's not a measurement of work. I'm sorry, just foot-pounds. And that is calculus for you, ladies and gentlemen. Haven't done it in 3 months, and I still got it. Thank you very much. Goodbye.